Large language models, or LLMs, are increasingly being used in specialized production pipelines across fields like finance, marketing, and e-commerce. These models handle tasks such as data processing, but they often fail to follow instructions or meet the expectations set by developers. To address this, researchers have introduced a new dataset called PROMPTEVALS, which focuses on creating assertions and guardrails for these LLM pipelines. The core idea is that developers need ways to ensure LLM outputs are reliable and aligned with specific requirements. For instance, an output might need to follow a particular structure or meet certain qualitative standards. Traditionally, improving LLMs involves collecting human preference data and using techniques like fine-tuning or reinforcement learning. However, these methods are complex and resource-intensive, and even after fine-tuning, models can still struggle with detailed instructions. Instead, the paper proposes a simpler approach, implementing developer-specified assertions. These are binary evaluation criteria that check if an LLM's output meets the desired constraints. If it doesn't, the system can automatically resample or retry the output. The challenge lies in defining these assertions effectively, as they vary based on the specific task, data, and user needs. Assertions must account for both objective rules and subjective qualities, sometimes even requiring LLMs to evaluate themselves. To tackle this, the researchers created the PROMPTEVALS dataset. This dataset includes 2,087 LLM pipeline prompts contributed by developers using open-source tools, along with 12,623 corresponding assertion criteria. Each prompt template has a median size of 191 tokens, making it substantially larger and more diverse than previous collections. It's over 5 times bigger than existing ones. The dataset was sourced from a popular open-source tool for building LLM pipelines, which has millions of weekly downloads and covers real-world applications in areas like medicine, finance, and sports. By analyzing these prompts, the researchers identified patterns in how developers define constraints, helping to bridge the gap between prompt design and output evaluation. In their experiments, the team used a holdout test split of the PROMPTEVALS dataset as a benchmark. They evaluated both closed-source models, like GPT-4o, and open-source models, such as Llama 3-8b and Mistral 7b. The goal was to see how well these models could generate relevant assertion criteria based on given prompts. The results were striking. Fine-tuned versions of Mistral and Llama 3 outperformed GPT-4o by an average of 20.93% in generating accurate assertions. Additionally, these open-source models offered lower latency, meaning faster processing times, which is crucial for production environments. This suggests that with the right fine-tuning on datasets like PROMPTEVALS, smaller, more accessible models can compete with or even surpass larger proprietary ones. The paper highlights several factors that make defining assertions difficult. For one, criteria differ widely between developers due to unique datasets, use cases, and end-user requirements. They also need to address common LLM failure modes, like hallucinations or inconsistencies, and incorporate qualitative aspects that aren't easily quantifiable. By providing this dataset, the researchers aim to advance research in LLM reliability and alignment. For example, it can help in prompt engineering, where developers refine how they interact with models to get better results. The dataset is publicly available on Hugging Face, allowing others to build upon it for further studies. Overall, PROMPTEVALS represents a practical step toward making LLM pipelines more robust in real-world applications. It emphasizes the importance of not just generating outputs, but ensuring they are trustworthy and aligned with human intentions. This work could lead to broader innovations in how we deploy and monitor LLMs, ultimately making them safer and more effective for everyday use.